All right, so we're going to look at problem 3 from this worksheet. 3 asks us to calculate the frequency and energy of blue light that has a wavelength of 400 nanometers. Now, it really doesn't matter which of these two I choose to do first. I'm going to calculate the frequency first, and I'm going to use the relationship C equals lambda F. So C divided by lambda is equal to F. I know that C is 3 times 10 to the 8 meters per second. Now I need to convert 400 nanometers to meters. I could do this one of two ways. I'm going to take the short way on this one. That's just 400 times 10 to the minus 9 meters. That's going to leave me with an inverse second as my unit for frequency, which is also known as a hertz. So either hertz would be acceptable for the unit, or an inverse second would be acceptable for the unit. And when we simplify this, we get 7.5 times 10 to the 14. Again, it can be an inverse second, that's okay. Or it could be a hertz, that's okay. I'm going to write both of them. Just choose whichever you prefer. And that answers the first part of question number 3. Okay, now we can answer the second question, which is to calculate energy. And I'm going to use the value we just determined. So I'm going to use the equation E equals HF. We know that H is 6.6260755 times 10 to the minus 34 joules times seconds times the frequency, which we just calculated to be 7.5 times 10 to the 14 inverse seconds. Now, I'm not writing it as hertz because I think it's important that you see that these units cancel. So the second and the inverse second will cancel when you multiply them. And now we're going to simplify this expression. And once I simplify this on my calculator, I get 4.97 times 10 to the minus 19 joules. It is true that if you have visible light, the energy of one photon of that light should be on the order of 10 to the minus 19 joules. We've seen this a couple of times now. It's just a nice internal mathematical check to see if your answer makes sense. Moving on to question number 4. We want to calculate the wavelength and energy of light that has a given frequency. Again, I would begin by calculating the wavelength. We know that C equals lambda F. So lambda is C divided by F. C is 3 times 10 to the 8 meters per second. F is given to us, that's 1.5 times 10 to the 15 hertz, which is an inverse second. Now this is really nice because the seconds cancel. I know that 3 divided by 1.5 is 2. And again, when you divide by exponents, you subtract them. That's going to be 10 to the minus 7 meters, or 200 nanometers. That's ultraviolet light. And for the second part, we know energy is equal to HF, or hc over lambda. I just prefer to do 2 steps rather than 1, or excuse me, rather than 3. So that's 6.63 times 10 to the minus 34 joules times seconds times 1.5 times 10 to the 15 inverse seconds. And again, when I multiply a second by an inverse second, that's second divided by second, they cancel out. Now all I need is to simplify this expression on my calculator. And when we simplify this expression, I get 9.95 times 10 to the minus 19 joules. So for number 5, we are given wavelength data and we need to calculate energy. So we want to use the relationship E equals hc over lambda. The only caveat here is we're given centimeters and we need to convert that to meters. So if we have 5 times 10 to the minus 2 centimeters, that's the same as 5 times 10 to the minus 4 meters. There's 100 centimeters in a meter. We've talked about unit conversions a lot, but at some point, you want to be able to do the easy conversions in your head without having to write everything down, because that just slows you down. So now the rest of this is just plug and chug. 6.63 times 10 to the minus 34 joules times seconds times 3 times 10 to the 8 meters per second divided by 5 times 10 to the minus 4 meters. So seconds cancel, meters cancel, which is going to give me a joule, which is exactly what I want. So now this is just a simplification problem. So the answer after we simplify is 3.98 times 10 to the minus 22 joules. So let's talk about number 6. So one of the things that we have not yet discussed is when we calculate the energy of a given wavelength, it is for a single photon of light. So the place where we want to begin number 6 is to find the energy of 1 photon of light. So we can do this with E equals hc over lambda. Of course, h is going to be 6.63 times 10 to the minus 34 joule times seconds times 3 times 10 to the 8 meters per second. Remember, that's the speed of light in a vacuum, which is what we use for C. And we're going to divide this by the wavelength. 10 times 10 to the minus 6 meters. And so now what we want to do is simplify to find the energy of 1 photon. So we come up with an energy of 1.99 times 10 to the minus 20 joules per photon. Well, we want to produce an energy of 10 to the 3rd joules. So we're going to divide this by 1.99. times 10 to the minus 20 joules per photon. This is a great exercise in good old-fashioned dimensional analysis because the joules will cancel and my unit will be a photon. And now all I need to do is to simplify this using calculator. And I get an answer of 5.03 times 10 to the 22 photons. So that would be the answer for question number 6. So we still have 4 more problems to go on this worksheet. I'm going to stop this video now because we're at about the 11-minute mark, and on the succeeding video I'm going to do the solutions of questions 7 through 10.